discussion. The first panelist of today is Professor Manuela Antonelli. The title of the statement is Modeling and Risk Assessment as Tools for a Resilient Drinking Water Infrastructure, the experience of the Politecnico of Milano. Manuela Antonelli is Associate Professor at the Politecnico of Milano, Department of Civil and Environmental Engineering, and her research activity is mostly addressed to advanced and smart solutions for drinking water and wastewater treatment and reuse, aimed at removing refractory pollutants and microorganisms, and pollutants present at trace concentration and evaluating the associated human health risk. Now, each panelist will provide a short presentation of about 5 minutes, and then we will start a discussion altogether. Thank you very much, Manuela, for joining us.
Thank you, Gabriele. I'm not sure you can see correctly my presentation. Can you confirm me?
Yes, I can see your presentation.
Thank you again. So, hello to everybody. Thank you for inviting me. And as you see here, the topic of my statement is modeling and risk assessment as tools for resilient drinking water infrastructure, the experience of Politecnico di Milano. Today, I think that fixed quality standards, both for microbiological and chemical parameters, are not enough to protect human health. The conventional approach based on the evaluation of the limit exceedance needs to be switched towards an approach based on risk assessment. In fact, we live in an interconnected system, which makes mandatory to evaluate the overall exposure of population to a certain contaminant, especially when we discuss about contaminant of emerging concern. Thinking to pharmaceuticals, we have a potential intake from additional exposure ways, being the presence in drinking water and the presence in edible crops irrigated with reclaimed wastewater. In addition, we have also risks related to the deterioration of water quality along the distribution network from a microbiological and chemical point of view due to compounds leaching from pipes and biofilm growth. Therefore, a risk-based approach represents a robust tool to support planning and prioritization of mitigation actions, since it permits to simulate and compare intervention scenarios, understanding their effective role in limiting exposure concentration. To practically implement a risk-based approach to control emerging contaminant spread, we need to synergistically integrate experiments, modeling, and a robust risk assessment framework, without forgetting to properly dealing with sensor data, meaning the data below the quantification limit, which are often a huge amount in case of contaminant of emerging concern, contrary to what happens with conventional pollutants. What we are doing on this topic in Politecnico di Milano. A way to upgrade a drinking water treatment plant is to optimize the activated carbon absorption process. This needs, first of all, a sound database of data describing GAC performance and reliable models to simulate GAC behavior. In fact, emerging contaminants and conventional pollutants behave differently, and the great difference of concentration makes challenging the efficient removal of emerging contaminants due to competition phenomena. Here you see a summary of the work we are performing in batch and column tests, varying the activated carbon and the type of water, to answer to important operating issues such as the GAC lifetime, considering micropollutants and emerging contaminant removal at the same time, and considering competitions among organics, and so on. Then we have developed a probabilistic risk assessment procedure to take into account the uncertainty associated to both exposure and hazard characterization. In fact, we have a wide uncertainty on emerging contaminant concentration in water, depending on GAC operations and source water. But at the same time, we have uncertainties related to toxicity of pharmaceutical compounds. Usually, risk is deterministically calculated as the ratio between exposure concentration and drinking water threshold level, providing a single value of the benchmark quotient. In a probabilistic approach, we consider the distribution of these variables, determining a distribution of the benchmark quotient, not a single value. And this provides additional information about acute risk and chronic risk. Last but not least, we have to consider leaching of organics from pipes affecting water quality for the end users. We know that leaching is possible, and this asks for preventive measures, consisting, for example, in the selection of the most suitable material and the planning of a proper monitoring campaign to highlight potential non-compliances and act as an early warning. Recently, we started to work also on microbiological stability in drinking distribution network to control the quality to the end user. In conclusion, I think that we need to approach the tomorrow drinking water production system as a unique system in which risk-based approaches can properly guide planning to prevent and not to cure. Finally, we don't have to forget to share knowledge if we want to guide the change and not to be guided by it. Thank you, and I hope to stay in my 5 minutes.
Thank you very much. Perfect timing, and we can move then to the second panelist. And then the discussion will open later. So Manuela, stay with us. The next speaker is Dr. Nataša Sovič from the National Laboratory of Health, Environment and Food in Slovenia. And the title of the statement is Emerging Contaminants in Slovenian Waters. Dr. Nataša Sovič comes from the National Lab for Health, Environment and Food in Maribor, and she's a chemist and specialized in chemical status of water. One of the specialty interests in the present status of emerging contaminants in Slovenian waters. So, Nataša, stage is yours. I see that already the presentation is visible. You can make it in full screen, and you can start. Thank you.
So, kind regards from Slovenia. So I prepared some short statement about pollutants in Slovenia. Emerging contaminants in Slovenian waters. So groundwater is source of drinking water for approximately 97% of inhabitants of Slovenia. From a chemical point of view, the quality of groundwater is directly reflected in drinking water quality. In Slovenia, 21 groundwater bodies have been delimited. In aquifers with karst porosity, with karst fissure porosity, the pressures are less intense compared to the alluvial aquifers. So for water sources in karst region, treatment is needed because of turbidity and presence of microorganisms. On the other hand, intensive agriculture, urbanization and industry are the main causes of pollution in alluvial aquifers. A poor chemical status assessed on the results of groundwater as well on the monitoring of results of drinking water was determined for 3 groundwater bodies. So in alluvial aquifers. Unfortunately, atrazine and destillatrazine are still present in groundwater and in some cases also in drinking water. So what we learned from atrazine story can we learn about modern pollutants? So the natural purification of groundwaters in aquifers is a long-lasting process, so modern pollutants are a significant concern. We have been monitoring pharmaceutical compounds in drinking water and groundwater for over a decade. Included since 2018, perfluorinated compounds can be found in 1/3 of sampling points in alluvial aquifers. For the most part, the concentrations are barely detectable, but we know they are there. However, it's important not to overlook this issue, as the compounds are very persistent and toxic. When it comes to the presence of pharmaceuticals in groundwater and drinking water, the situation is good, favorable for now. Meanwhile, considerable remains of pharmaceutical compounds can be found in surface water. So wastewater treatment and treatment plants is only partly effective in removing pharmaceutical compounds. Slovenia, some compounds are extremely harmful to water organisms. Slovenia has a good monitoring system for surface water, groundwater, and drinking water. A lot of data is available, although it is somewhat dispersed. However, the origin of pollution by modern pollutants remain largely unexamined. We absolutely believe that the wastewater monitoring parameter and programs for monitoring water and landfills need to be updated. The data on sources of pollution could be then used to establish pollution reduction mechanism. Drinking water related, the watch list mechanism should make it possible to respond to growing concern in a dynamic and flexible way. So we know drinking water directives is under revision, and we expect update in a few months. Risk-based approach should be implemented in monitoring programs for drinking waters. Thank you for your attention.
Thank you very much, Nataša, for this overview about the Slovenian situation. The next statement brings us to Poland, and will be given by Dr. Anna Kuczyńska, and it will be monitoring of emerging contaminants in groundwater in Poland. Dr. Anna Kuczyńska works for the Polish Hydrogeological Survey and is currently the head of the groundwater monitoring department in the Polish Geological Institute of Natural and the Natural Resources Research Institute. She is specialized in groundwater risk and status assessment, in particular using a quantitative approach. She's also an expert in the groundwater expert group operating under the framework of the Common Implementation Strategy for the Water Framework Directive, and also contributes to the work of the Groundwater Watch List expert group, also under the CIS framework. So, Anna, stage is yours. I see that already the presentation is properly shown. Please unmute your microphone. Thank you.
Hello, everybody. Am I heard?
Yes, you can go ahead.
Thank you very much. Thank you very much. Well, first of all, congratulations on the very good conference today. I'm very pleased to see all this information. So I'm here to tell you a little bit about the way we monitor emerging contaminants in Poland. As I was introduced, I'm the head of groundwater monitoring department in the Polish Hydrogeological Survey, and we are responsible for doing the groundwater quality monitoring on the national scale. So,
the microphone is not working anymore.
Okay, thank you.
Okay, thank you.
So first of all, few brief information about the water resources in Poland. The estimates for our disposable groundwater resources are at about 34 million cubic meters a day. And we have registered abstraction at the level of 7 cubic meters a day. 65% of these registered abstractions contribute to drinking water supplies, which is quite high. We have
the microphone is off again.
We have about 16,000 water supplies in Poland, and about 70% of water for human consumption comes from groundwater. On a national scale,
I think we are facing some technical issues with the talk of Anna. It looks to be frozen at the moment. Joanna, could you please take over the control again?
Yeah, we'll see.
And my suggestion is that we move to the next statement, and then as soon as Anna will join us again, we can get her contribution related to the Polish situation.
Yes, I think so. Okay. Okay, so
the next statement brings us to the Czech Republic, and it's about modeling approaches in transport of PPCPs in a Káraný waterworks area. And the talk will be given by Maria Mursaikova. I'm sorry if I don't pronounce properly the family name. And she's doing the PhD at the Czech University of Life Sciences at the Department of Water Resources and Environmental Modeling. Since 2012, she had dealt with studying and modeling of environmental pollution. First, she worked on the impact of oil refining industry on soil and water environment in Russia. Then she moved to study site in Czech Republic, and now she's applying her previous knowledge to the boDEREC project. So thank you very much for sharing your experience.
So good afternoon, everyone. Today I would like to say a few words about our modeling approaches in transport of pharmaceutical and personal care products in our pilot area, which is Káraný waterworks. So a brief information about pilot area.
Sorry if I interrupt you. Do you want to share a PowerPoint presentation? Because at the moment you are not sharing it.
Yeah, I share it.
I don't see it, at least.
Is it okay now?
Yes, perfect. Thank you very much.
Okay. Brief information about our pilot area. There are two independent water treatment systems. First is bank infiltration, and the second one is artificial recharge. Geologically, area belongs to the Bohemian Cretaceous Basin, and the topsoil overlay is created by terrace deposits of various degrees, range from fluvial sands to gravelly Pleistocene sands. Many terrace deposits are sedimentstone, sandstone, and marl. So in our model, we are considering with unsaturated and saturated zone, and also we are considering with critical meteorological conditions such as extreme drought and heavy precipitation to study behavior of PPCP under this condition. For this task, we decided to use a two-dimensional model, which is a cross-sectional model. So how we do it? We have collected a geological data and digitalized it to borehole representation. Based on it, we have created each needed cross-section of aquifer and then applied on this cross-section triangulated irregular network, which is absolutely necessary to run the model in Truth's software's environment, which is created in our department for different scenarios of solute transport model. We use ArcGIS software with ArcHydro groundwater tool, which is created by Aquaveo. Then we use a finite element mesh generator and the Roots software. Why we choose this approach? It have a few benefits. First of all, a two-dimensional model will be helpful to correct and avoid mistakes in our future three-dimensional model. A cross-sectional model also can display a hydrogeological heterogeneity of aquifers that may affect contaminants transport, and it takes less numerical dispersion with a reasonable computing time than the three-dimensional models. So it can be run and calibrate much more quickly. That's all. Thank you for your attention.
Thank you very much for your statement. And I would like to check before we move on if Anna Kuczyńska is back online.
I don't think so. We contact her and we will wait. Okay?
Okay, perfect. Thanks. Then we can move on with the next statement. We are going to talk now about the situation in Austria with engineer Manfred Eisenhut. So with the title Management of PPCPs in Water Cycle from the point of view of water suppliers in Austria. He is employed by OVGW since 1986, and he's the head of the water department for more than 20 years. Since 2003, he is the Secretary General of the Austrian IWA National Committee, and he's also responsible for OVGW representation in Brussels. He is also the coordinator of cooperations between OVGW and other international organizations like IAWD, IWA, and EURAL. So, if you can share your presentation, we are ready to start.
Hello, everybody. Thank you for the introduction. Joanna, is it possible that you make the presentation of my slide? It's only one slide.
Yes, I will try. Could I ask Maria to switch off her sharing the screen before we do this?
Yes, thank you. I'd like to give you a short overview about the Austrian situation on ECs. OVGW is an association who represent more than 1,500 water suppliers in Austria. Overall, we have approximately 5,500 water supply companies here in Austria. We are involved in discussions about emergency contaminants on the national and European level. And I like to say, first of all, thank you for the excellent presentations today. I learned a lot about this project and it's very interesting. In Austria, we use only groundwater from springs and wells as drinking water resource. Drinking water treatment plants are the exception. We use mostly natural water, natural groundwater, and our groundwater is our drinking water is directly affected from pollutants. As in Slovenia, we have a very good monitoring system. The government manages systems of approximately 2,000 boreholes to monitoring the groundwater system, the groundwater quality. Every year, the government starts special programs to monitor different chemical substances. In the last years, more and more emergent contaminants. The results are published in the for the public, and we as association, we required that in the results there must be a comparison between the measuring results and the human toxicological threshold for water. This is a very important topic. So the results of the monitoring program in groundwater are very low. We don't get a public discussion about these emergent contaminants. But it is absolutely important to monitoring DECs, to lead the discussion on the EU level about circular economy, extended producer responsibility, the chemical strategy, the pharmaceutical strategy, and something else. In the frame of the EU Green Deal. This is the beginning of a discussion where we need more data and knowledge about ECs. We need this political discussion on the EU level about the possibilities to avoid ECs at the point of source. The water supplier has the last position in the chain. Therefore, we need research and knowledge to lead the discussion to avoid ECs at the point of the source. And one part of the EU Green Deal is the zero pollution strategy. And we know that with the possibilities of the modern analysis, a discussion about zero pollution is not possible. This makes no sense. And from our point of view, it's also very important to differ between eco-toxicological and human toxicological thresholds and make clear that zero pollution is really not possible. Zero pollution is not a strategy, it's maybe an aim, but not a strategy. So we welcome this project because this project creates knowledge for the future discussion. And once again, I heard a lot of right things today and say thank you for this. Thank you.
Thank you very much for the appreciation of the project and of our work, and thank you very much for your important statement. So, Joanna, I move on as long as you don't tell me that Anna is back.
I think Anna is back already, so if we are ready, Anna?
Yes, I'm here again. I'm sorry, I have some technical difficulties. I'll try now to share my presentation again. I don't know where did I finish.
I think it was more or less still in the beginning. I think just the first couple of slides have been shown. But at the moment, I'm not able to see your presentation.
We can also use me as a sharing desktop to your presentation.
Yes, I think this would be a good solution.
Okay. Let's try this. I'm not sure if we have now more technical issues. Anna. Okay, I think we can skip for now because I think there was something again. Sorry,
okay.
Gabriele.
Then we can go on with the German experience. We have Dr. Daniel Bittner presenting today a statement with the title PPCPs in river basins affected by mine drainage, a challenge for future contamination assessment. Daniel was a PhD student at the Technical University of Munich. He worked also on the boDEREC project up to a few months ago, and now he is part of the Verband. So he moved, let's say, to the stakeholder side. So, Daniel, stage is yours. You should unmute your microphone.
That seems logical. Can you all see my screen and hear me now?
Yes, now everything is fine. Thank you.
Perfect. Thanks for the introduction. Yeah, as Gabriele introduced, now I'm working for the Verband. The Verband is an association dealing with all kind of water aspects in the Erft River catchment close to Cologne. So we are working with in the areas of wastewater treatment, surface water hydrology, groundwater hydrology, manage also the water supply. So we are doing a holistic approach in terms of water management in an entire catchment. Come on. So the catchment we are dealing with is a tributary for the Rhine River, which you can see on the right-hand side, close to Cologne. And our catchment can be subdivided in the upper part, located in the south, which is part of the Eifel mountain range, and the rest is mostly dominated by agricultural areas. However, a big part. Something's not working. However, a big part, and this is the main, let's say, the biggest anthropogenic influence we have in our area comes from lignite mining areas. So most of you probably know the mine areas of Hambach, potentially also Garzweiler. So you may think that this is only affecting the groundwater, but it's not. Of course, the people who are managing these lignite mines have to draw down the water table a lot, and a lot means partially around 400 meters to avoid any kind of infiltration into the mines. Then the lignites are processed on the right-hand side of the Erft River and burned, and of course you also need water to cool down your system. And this water from the water table drawdown that is continuously pumped, as well as the processed water for cooling, is all discharged into the Erft River. So starting from the point where you can see the Tagebau Hambach, the lowermost mine, we have partially more than 50% of the water which is in the Erft River that is only related to the discharges related to the mining. In 2018, we had a project that ended related to a survey related to PPCPs. And I want to show you this as an example for diclofenac because it was one of the most prominent substances that was found. From left to right is the flow direction of the Erft River. And if you look, for example, at some points where you can see the peaks of concentrations, these are all related to water treatment effluents. And what is happening afterwards is just a natural decomposition of the substance itself. But if you look at this large drop down here, this is where all the effluents, the discharges from the mining activity start, and we have a huge dilution effect. So at the end of the 2020s, the mining will stop, and no mining will further continue. And of course, also the discharge from mining activities will stop. So this means just suddenly the river will lose about 50% of its runoff. So concentrations will certainly change without the mining related discharges. And the future contamination assessment due to these changes is highly uncertain. Thanks for your attention.
Thank you very much, Daniel, for this interesting presentation. We remain in Germany, and the next speaker is Dr. Jan Leo from the University of Freiburg. The title of his statement is Conceptual Equifinality Modeling Emerging Contaminants. Dr. Jan Leo did the doctoral study in the Center for Applied Geoscience at the University of Tübingen, and his thesis was focusing on modeling the fate of micropollutants, including sediment-associated and dissolved compounds in rivers. After that, he moved to the chair of hydrological modeling and water resources at the University of Freiburg as a postdoc researcher working on karst hydrogeology. His research interests include catchment scale hydrological and solute transport modeling, groundwater and surface water interaction, regional to global scale modeling of karst water resources, and model development for pollutant transport in karst region. I see that you already shared your presentation. Please put it in full screen modus, and it seems that also your audio is on, so once you put it in full modus, then you can start.
So can you see my screen now?
But I can see only one single slide, not in full screen.
But now is full screen, or? Because it's the full screen in my computer.
Not yet, at least for me.
Okay. So now is that okay for the full screen?
Now I still see it, let's say, in the PowerPoint modus to work on it, but I can tell you when. So you can change slide by slide maybe. On.
Now it's fine?
Because no, not yet actually.
Okay.
Did you send your presentation to Joanna?
Yes, but I have some animation in the presentation.
Okay.
Maybe you should use F5 button on your keyboard.
F5, not like, okay. So now it's full screen on my computer.
Okay, so it doesn't work. You do not want me to share your presentation, right?
Because there are some animations. If you So now it's at fine?
No, unfortunately.
It's still not?
No.
No, but maybe I can tell you when you should change the slide, because but you have the animations. I think then you should try to give the presentation as it is shown now.
Okay, so thank you, Gabriele, for the introduction and also for the invitation. So today I want to talk about the conceptual equifinality in modeling emerging contaminants. So estimating the removal of emerging contaminants in streams requires an understanding of degradation processes and also the degradation hotspots. The trend-storage modeling is widely used to simulate the fate of such compounds. The trend-storage modeling usually considers the hub-height zone and also the surface zone, which are believed to be the bioactive layers. However, the equifinality is often present in the trend-storage modeling. So the equifinality can come from the model conceptualization and also from the parameter estimation. So here to explore the equifinality in the trend-storage modeling, we have a case study. The studied river is located in Tübingen, which is in southwest Germany. So this river receives effluent from a wastewater treatment plant. My former colleague performed day and night TRISAT campaigns using sodium fluorescein. And at the meantime, we took samples from the river to measure the pollutant concentrations at the 4 downstream measuring stations. So this photo shows how the river looks like on the low flow condition. We can see the stagnant pores and also the biofilms on the riverbed. To conceptualize this system to try the story model, we use a model on the right hand. So we conceptualize it to a main channel and a transit storage zone. For the main channel, we simulate the transport and also the biodegradation, photodegradation. But for the transit storage zone, we separate it to the surface and subsurface transit storage zone. The difference between the two transit storage zone is that the photodegradation is only taking place in the surface transit storage zone. So that's a general transit storage zone modeling. To fix the model with TRISA breakthrough curves, we can show the equifinality of surface and subsurface transit storage zone. So for the night TRISA experiment, we can see this figure. The TRISA is almost conservative. By fitting the night TRISA breakthrough curves, we can estimate the total transit storage fraction. So for the day TRISA experiment, the TRISA undergoes photodegradation. By allowing the photodegradation in the surface transit storage zone, and based on the night TRISA experiment, we can estimate the ratio of surface and subsurface transit storage zone. So from that, we can see combining the conservative and reactive TRISA, which enables us to estimate the surface and subsurface transit storage. We also set up 2 scenarios to show the equifinality of degradation processes. So this figure shows the average removal of 4 representative pharmaceuticals over a 1,300 meters reach for a 24-hour period. So for the 2 scenarios, we have different processes taking place in different river domains for the biodegradation. So for the first scenario, we only have biodegradation in the transit storage zone. But for the second scenario, we have the biodegradation taking place at both the main channel and the transit storage zone. So from this figure, we can see the total removal, the total pollutant removal is almost equal on the 2 different scenarios, but we get significant different rate coefficient and the different attributions of degradation to different river domains. From this, we can see attributing degradation to different river domains is difficult at a single flow rate. It also brings difficulties to predict the removal of emerging contaminants in a different flow rate because the rate coefficient will change with the change of the settings of trend storage zone. So for the discussion and conclusion, we can say combining conservative and reactive tracer experiment is helpful to differentiate surface and subsurface trend storage zones. Conceptual equifinality leads to difficulties for attribute degradations to different real domains and a single flow condition. Predicting pollutant removals requires measurements on the various flow conditions. Thank you for your attention.
Thank you very much for your talk. Unfortunately, it was not possible to see the change in the slides. So it would be nice if it would be possible maybe to share the presentation, or if you like, we could try to record your talk again, trying to go through the slides as well, because unfortunately it was frozen on the first slide. Now your microphone is off. It is still off.
Yeah, you need to raise your hand, please. Oh, maybe now.
Yeah, because I was, I think we switched to another presenter, so I can record the presentation and send it to you later. Sorry for the technical issue.
Thank you very much, but the point was quite clear. Thank you.
Yeah, thank you.
So now we move this time quite far away from Central Europe, since we moved to Chile. Dr. Paulo Herrera is going to present us modeling and monitoring emerging contaminants, a perspective from Chile. However, he's beside being a consultant and being affiliated to the university in Chile, he is a currently visiting researcher at the Department for Environmental Geoscience of the University of Vienna. Paulo works as a consultant in water resources. He graduated as civil engineer from the University of Chile and obtained a master's degree in hydrology and hydraulic engineering at the University of Urbana-Champaign in Illinois. And he also owns a PhD in geological engineering from the University of British Columbia in Canada. So he has really a broad let's say, overview about problematics related to groundwater resources. He was also a researcher in Norway, and as I said, he was faculty at the University of Chile, and he's also part-time lecturer in Chile as well as in Canada. So thank you very much, Paulo, for joining us. We can see your presentation, but we cannot see it as full screen at the moment. And I think your microphone is off.
Yes, thanks, Gabriele, for the invitation. Can you see my presentation full screen now?
Yes, perfect.
Yes, okay, thanks for the invitation again for this nice conference. I have enjoyed listening the presentation this morning and learning about this subject, which is quite new to me. So I will give you some thought about modeling and monitoring emerging contaminants, and will be from a point of view from Chile. So I thought I should start this talk by telling you something about Chile that I believe is related to the topic. So Chile has several large mines, some of the largest in the world, in fact, for copper mining. So here there are some examples. There is Chuquicamata, which is owned by a public company, national company, Codelco. We also have Escondida, which is owned by an international company, BHP. And then Los Bronces, which is near Santiago, the capital, which is owned by Anglo American, all big international companies in mining. So these mining projects have presented few challenges. Some of them are located in northern Chile, which is one of the driest places on Earth. So there are problems related to water supply. There are also other mines that are located in the Andes at high elevation in the central area of Chile, and they presented some problems for drainage of the mines. So tunnels and open pits to be able to operate them. But also some large facilities that are related to mining activities, such as tailings impoundments. And there are two quite big near Santiago, the capital. So just to give you a scale here, 6 kilometers long, and some of them are even larger. So they also a need for environmental studies. So all this mining activity has developed sector services focused on the mining industry that includes national and international consulting companies that provide services on water resources and also on environmental studies, which is, I believe, is related to the topic of this conference. So recently, I work mainly on that kind of project, but recently I came across this word, gadolinium, which caught my interest, which is a rare element that is used for magnetic and MRI exams. And is currently used also as anthropogenic tracer to study groundwater and surface water pathways in different rivers around the world, including in Europe. So since I also was invited to this conference, I read few papers about the subject, and I discovered that there are very few studies, almost none, in South America about these PPCPs contaminant. There are only 2 reports based on these reviews, more than 140 publications, one or two from Brazil and one from Colombia, but they talk mostly about personal care products. So thinking about this, how this could affect in Chile, and thinking about what are the main pathways for the PPCPs to reach surface water, we have that one of the main points here, steps, is the treatment plants for drinking or for wastewater treatment plants. So thinking the situation about Santiago, since the 1990s, most of the wastewater in Chile is treated, which was considered a large improvement at that time, solved many issues of public health. So around mid-90s, it was inaugurated this plant in Santiago that covers half of the population of Santiago. I think at the time was considered the largest wastewater treatment plant in the world. But now thinking about these PPCPs, maybe we should start thinking how the location and the operation of this facility could impact the rivers, and particularly downstream the Valley of Santiago. So I quickly review what are the main components that are considered PPCPs, and this is from the US regulation. And then I compare that with the standards that we have in Chile for different discharges. For example, this one is for discharge limits for discharge to sewage system, which is from 1998. It lists mostly the standard substances that are considered as hazards for public health, but it doesn't list any PPCP. Same for the one that the standards for discharge to surface streams and ocean. Same for the one for groundwater, and same for the one that defines what should be considered as toxic waste. So since there are no mention to PPCPs, that made me think that probably it's also not a lot of analytical capacity to detect them. But I am not an expert in the subject. I'm just thinking that since there is no standard, probably there is no need to do this kind of periodically. So final thoughts, PPCPs are a new source of concern for the water quality for different uses. There seems to be little information about the status of their presence in Chile or South America. as far as I know, and based on this quick review, as I told you, this subject is new to me. However, in Chile, there is a know-how about water resources and water pollution developed for other purposes that could potentially be applied to this problem. But I believe, again, that the lack of laboratory facilities could be an issue, and this is based in my experience with other kind of analytical techniques used in environmental studies, for example, analysis of isotope. Until not so long ago, there was no lab in Chile that could perform them, so maybe this is the case for this kind of contaminants too. So thanks again for the invitation and your attention.
Thank you very much, Paolo. It was interesting also to see how the situation seems to be outside our specific area and outside Europe in order to see how the problem is perceived abroad. And now we go to probably the last speaker, as long as we don't get back our missing talk before. We are happy to welcome Bojidar Japalya, Head of Business Development Planning Department of the Split Water and Sewage Company. The title of his statement is "Healthy water is a basic need and prerequisite for any sustainable civilization." And he's a civil engineer, and he works for the Split Water Company since 1983. Covering different positions in the companies, from supervising engineer, CEO of the technical sector, director of operation, among others. And from 2005 to 2009, he was deputy mayor of the city of Split, responsible for spatial planning, city infrastructure, and city property. And he's member of the board of National Group of Water Service Companies. So, thank you very much, and we welcome your talk.
Okay, but I think there will be a problem with my presentation, but I send one to Joanna, so you can proceed with the, yes, that's it, okay. You can move on every 15 seconds and I will talk about presentation. Okay, the name of presentation is Healthy Water is Basic Need and Prerequisite for Any Sustainable Civilization. That's the truth. At first we had the water and then life emerged from water, and many centuries ago we've got first civilizations. So this my water company use a part of ancient Roman aqueduct, and the first the source of River Adro was captured in Roman times, and they were extraordinarily good engineers. They had in that time water supplying and water drainage for their cities, and in the nearby the city of Split now is city of Solin. In Roman time there was a great town, Salona, the biggest one of the eastern part of the Adriatic Sea, with more than 60,000 inhabitants, and they had water from source of River Adro, which is a typical karst spring. Actually an overflow in the contact with clay layers and karst terrain, and they captured that source in first century before Christ, and after that, in the ending of second century, the Diocletian Palace was built by Emperor Diocletian, and this facility also used the river from Jadro source for water supplying. So we count that we got, you can move on slides please, organized the water supplying from the first century before Christ, and it lasted many years on until the Avars and Slavs came to this area, and they destroyed Roman aqueducts, and the area was without organized water supplying until the year 1880, and that is very important year for us because we counted the beginning of the second phase of organized water supplying in Split's metropolitan area, and in 2005 we're celebrating 155 years of organized or of my company, because city of Split reconstruct all Roman aqueduct, and until now we use it for some quantity of water for the city of Split. We still use that Roman aqueduct, and that is the only case in Europe for bringing towards the Split reservoirs more than 400 liters per second. You can go on. What I want to say, there would be no civilization and no cities Split, Solin, Caștele, Trogir as we know today if there wasn't a source of River Jadro there, and it was very rich with good water. Even now, as you can see in previous presentation, we have small quantities of emerging contaminants in the water of Jadro, and we have to prepare for the future time, because this is the only source of water for us now. So we have to keep the catchment area of the river, and it is more than 400 square kilometers wide. So it is very important to have a good monitoring system, not only for the water on the source of River Jadro, but also for the whole catchment area. We have to implement quite a number of boreholes for monitoring the groundwater. And that is the only way that we can know what are the trends in water pollution. As we all know, there is no analytical capacity in waters today to detect emerging contaminants, especially PPCP in water that we use for drinking. So you can see that in this project we have several pilot activities for identifying main emerging contaminants for the group of PPCP and their behavior and fate in different hydrological conditions. So we are focused on karstic catchment, and we will proceed with this because at the end of the project, we will have the procedures and strategies to mitigate this problem in water supplying. That's all for me today. You can go on last slides.
Thank you very much.
Yes.
For the nice contribution. So I just want to be sure that we didn't manage to have back Anna.
Yes.
So we proceed then with the discussion. Right, Joanna?
Yes.
Okay.
Yeah, Anna is now a presenter, and I will show her presentation because probably this was the problem.
Yes, I'm back. Sorry, I'll switch on my camera. Hello again, maybe the first time will be lucky. I asked Joanna to present my presentation because this seems to be causing the problem. So if you could, Joanna, start, then we can try. Yeah. Okay. I don't know, did I finish before? So I will start from the beginning. So I will tell you a little bit about the monitoring of groundwaters in Poland. As I was introduced, I work for the Polish Geological Institute, and we are subcontracted by the Chief Inspectorate for Environmental Protection in Poland to undertake the groundwater chemical monitoring. So next slide, please. The small introduction of the Polish water resources. We are fairly resourceable with groundwater resources. They are estimated at circa 34 million cubic meters a day, and our registers abstractions go up to circa 7 million meters cubic a day. Next, if you could click. Most of this water is abstracted for drinking water supplies, which take about 65% of what we register at present. And this goes to circa 16,000 water supplies in Poland. It is estimated that about 70% of water for human consumption comes from groundwater, so water quality is of high importance to us. Next slide, please. When it comes to quality monitoring in Poland, our current legal requirements refer to those requirements that are given by the Water Framework Directive. And specifically, they require us to undertake the monitoring campaigns such as surveillance monitoring, operational and research monitoring. They also give us a list of obligatory parameters that we shall monitor, and they contain 55 parameters at present, including inorganic and organic parameters. Some of them are general parameters, most of them are contaminant parameters. Next slide, please. Unfortunately, none of the new emerging contaminants that we spoke about today during this conference is not included yet in the legal requirements that we have in Poland. And this is a big difficulty for us because this does not allow us to use the national funds to undertake such monitoring. And most of the work on the monitoring of new emerging contaminants is done on the scientific-based project, not in a framework on the national monitoring programs. This might change in future because, as most of you know, there is a directive that came into force in 2014, which amends annexes to the directive, Groundwater Directive. And this directive says that there is a need to look for new information about new contaminants for groundwater, and requires the European community to establish a watch list for pollutants of groundwater. And this work is ongoing. Next slide, please. There is an expert group working for the European Commission under the Common Implementation Strategy, which developed a methodology how to set up such a groundwater watch list. This was done over the years 2016, 2019, and then the first list facilitating Annex 1 and Annex 2 revision has been established in 2019, and also a first groundwater watch list. This process for groundwaters is still voluntary on the EU level. It's not obligatory, and so countries can do monitor, but they are not required formally to monitor new emerging contaminants in groundwaters. Next slide, please. Next slide. So what's on the lists with respect to this interest of this conference, because we were talking about PPCs. The first groundwater watch list, the first facilitating the Annex 1 and Annex 2 revision process, contains in total 12 parameters. which has been defined at the EU level to be well monitored and also quite spread. And these are the parameters that are recommended for the revision of Annex 1 and Annex 2, the Groundwater Directive. There are two pharmaceuticals on this list, carbamazepine and sulfamethoxazole. And sulfamethoxazole. There's also, next slide, please. There's also 7 parameters pharmaceuticals on the first groundwater watch list, and these are listed here. So these are the parameters that seem to be of high importance with respect to groundwaters. And for these parameters, the member states should try to develop monitoring strategies at present to gather information on their spread in groundwaters across Europe. Next slide, please. So what we did in Poland, knowing what was going on in Europe and having access to information on these studies from other countries, was we performed a research study in 2016-2017 that aimed at screening our boreholes that we have in our national groundwater monitoring network for the presence of pharmaceuticals. And we've done this in 160 locations, and our interest was in 34 active substances of pharmaceuticals. Next slide, please. And these are the pharmaceuticals that were included in our study. There are also 4 parameters that are actually now on the list facilitating revision of annexes and also the groundwater watch list. Can I have next slide, please? As you can see on this graph, there was quite a good response in our study. We actually found 24 out of 34 substances that were included in the study, which gave us 70% of the response rate. Next slide, please. So we found pharmaceuticals in over 50% of all sampling points, which seems quite a lot. It was a targeted study, but we did not expect to have to find pharmaceuticals in such a big amount of boreholes. As I said before, 70% of analyzed in questions were found in our study. As in most other studies, the most common substance was carbamazepine, but we also found sulfamethoxazole, ibuprofen, antibiotics like enrofloxacin, sulfamethoxazine, and also other compounds. Next slide, please. So from the perspective of the groundwater status assessment, which is in our competence, we find these results very important because they probably will change the perception of the groundwater status assessment in future. Once these substances will be included in the list of parameters that can cause groundwater bodies at risk, this might impact significantly results of the groundwater status assessment. The problem that we have, I guess, is what are the safe limits for groundwaters, because we have to establish now the threshold values that will allow us actually to perform groundwater status assessments. And this is a difficulty that I believe is a common to many of us who deal with the emerging contaminants. Definitely, there is a big need for a discussion, a broad discussion about the emerging contaminants in groundwater between all stakeholders, including environmental agencies as well. And thank you very much.
Thank you very much. I would like to thank all the panelists that provided a very interesting contribution to the project and to the conference of today. Unfortunately, we are a little bit late due to some technical difficulties, but I think there is time at least for a couple of questions. And I would like, first of all, to have a really, let's say, sharp answer from the panelists for what concern, in your opinion, the single most important knowledge gap that we need to fill to detect and assess PPCPs in drinking water. So you can be biased, of course, considering your field of expertise, but I would like to have just the single one most important point, in your opinion, that should be definitely improved. It could be, I don't know, detection limit of the instrument, development of a new model, development of a new conceptual model. So maybe we can proceed in the same order as the panelists presented. So we could have first one sharp answer from Manuela.
Could we ask Manuela to raise hand in the Teams?
She did it.
Oh, okay. Thank you very much. Now you can.
Maybe we could activate all panelists already, because otherwise it takes too long. Thank you.
Yeah.
Okay. Very rapid answer. I'm an environmental engineering, and from this point of view, I think that one of the gaps we have to fill is related to the behavior of the process removal, of the removal processes specifically for emerging contaminants. We know a lot about the behavior of removal processes with respect to conventional pollutants, with respect to micropollutants, but we don't know, we don't have a sound knowledge about emerging contaminants in full-scale conditions. We have some studies at lab scale, at the pilot scale, but not in full-scale condition, considering all the factors affecting the removal. And this is of great help for managers of water utilities to improve the water quality.
Thank you very much. And Nataša, what is your opinion?
Yes, I also think we should improve wastewater treatment. On the other hand, I think we need analytics upgrades, so we can include also metabolites of personal care products and pharmaceutical.
Thank you. Then we move to Anna.
From the groundwater perspective, I think what we really need is the information about what is the safe limit. What is the safe limit for drinking waters? Where is the safe limit for also ecological indicators? Because the groundwater, in the framework of groundwater status assessment, they've got a number of different receptors, and one of them could be surface waters. Some of them can be groundwater dependent terrestrial ecosystems with its fauna, and also the drinking water. And it is very difficult for us to think about how we will assess our groundwater status if we don't have information about what are safe limits for those.
Thank you very much. Maria?
So I think we need more studies about behavior of PPCP under different meteorological conditional, like how drought and heavy rainfall, heavy precipitation, which impact it has on the concentration of PPCP in water environment.
Thank you. Manfred?
Yes, thank you. We need thresholds for the human health and ecological thresholds. And I think before we analyze emergency contaminants, we need these thresholds that we can compare the resides with the need. Thank you.
Thank you very much. Daniel?
I would also follow the answer of Manuela that we need to enhance our understanding of the processes that are governing the transport through our entire catchment series. So not only focusing on one single system like a fluvial system or groundwater system, but trying to understand how and which substance is behaving how and where.
Thank you. Jan?
Thank you. So as a modeler, I think I have some opinions about modeling part. So because now we are focusing on either surface systems or the groundwater system, including the karst systems or NACA systems, but we should also focus on some interaction between the groundwater system and the surface water system. So that means we have to look at the losing river system and gaining river systems to look at some interactions between those systems.
Thank you. Paolo? You have to unmute your microphone.
Sorry. I agree that it's key to defining safe limits, and based on that, also see how difficult it is to detect concentrations at that such a low values, and then also make a trade-off between cost and risk. I think that is key for when you implement these kind of public policies.
Thank you. Bojidar?
I would like to say first that we have to have a holistic approach for this problem. That is very important to collect all kinds of experts and scientists, because otherwise we wouldn't solve the problem. And why I'm talking this? Because it is not only important to set the thresholds of PPCP in water, and it is very important to reduce the possibility of get those substances in the water. And many important thing and fact is that today tens of millions of people on the earth die because of polluted water. And we all know this pandemic, how much media upset about it, and nobody cares that more than that people dies because of polluted water. And that's why we have to go in public and to decision makers to get steps ahead and to mitigate these problems. Otherwise, we wouldn't succeed to have a good life on the earth.
Thank you very much. Joanna, may I go with another round of questions, although the official time is over?
I think so. I hope everyone will still with us. If not, please leave just room if you don't have much time to participate. But I think, yeah, if panelists agree, we could still be here in this room.
So I would like to ask you the following. So we have seen that long and highly resolved in time series of PPCPs concentration are quite uncommon. So very often such measurements are done on spot, but we don't really have a dynamic behavior of PPCPs available for many sites. And I wanted to know how this affects your daily work, and which kind of suggestion you would like to provide to policymakers in order to improve such a situation. Connecting again to the comment made by Paolo, I think, cost risk assessment is needed, because we know that these kind of analyses are not as cheap as they are, for example, the analysis for standard contaminants, at least at the moment. So again, maybe we can take the same order as before, since I would like to have the opinion of all of you. So Manuela, you can go ahead.
It's my turn. I think that we need to switch our mind from the conventional monitoring campaign when we make a lot of samples, a lot of analysis, because these analyses are not so costly for us. We have to switch integrating monitoring campaign with modeling to suggest us when is best, which is the best moment to collect a sample, for example, because I think it's not affordable to have long time series, to have huge database for emerging contaminants at the moment and in the near future. So we have to couple modeling tools to exploit their potential in suggesting us when is the best moment to collect samples, to obtain a time series or a database which is representative of a certain contamination situation, but considering the efforts we need to make analysis.
Thank you. Nataša?
Yes, I think we can have a cost-effective monitoring. I also think we can do the math with mass balance, what we use, how many we use pharmaceuticals, how much we find that in sewage water and in a sludge, and what can we expect then in groundwater and surface water. So I think there are models for that, and it's not necessary to measure that all. We can also calculate with amount of these products. Thank you.
Thank you. Anna? Oh, microphone.
Sorry. Yes, I agree with both ladies before me, but also would like to add that we probably need some priorities in what shall we monitor and some indicators, because there is many of these substances and there will be more, because it's really up to the limits of our equipment that is used for analysis. So I think we should also focus on trying to find some indicators that would be firm and stable, and for those we should continue with continuous monitoring probably. Thank you.
Thank you. Maria? I think the microphone is off.
Yeah. Is it okay?
Yes, perfect.
Okay, I want to say that now we are trying to install our own data logger to take more information for monitoring, and I hope it will be helpful for our researchers. So I think the only one way is make more analysis and take more samples.
Thank you. So, Manfred?
Yes, if we like to clean our resources, hold it clean, then we have to monitor our water resources. We have to pay for it, but it must, we have to find a way to make it realistic. It's not realistic to monitor more than 100,000 chemical substances who are listed at the REACH list. So we have to find a new way to define the substances we have to monitor in our resources to have a good solution to keep our resources clean. But we have to pay for it.
Thank you very much. Daniel?
Yeah, I also see that in order to close the gaps in a better way, we need to find ideas how we can use modeling tools in order to improve our understanding of the behavior of these substances and to fill data gaps by well, any kind of models that help to understand better the behavior of these substances.
Jan?
Yeah, I think it's a very good question about the temporal dynamics. So from my point of view, I think we can, so for sampling schemes, we can use like region sampling schemes, which means we can follow the water parcel along the flow direction. Then when we take samples at different locations, that means we can include some temporal dynamics from the region sampling schemes. And then from modeling part, I think for some emerging contaminants such as PEH, PCBs, we can look at the transport of sediments. Then if we know some characteristics of absorption of this kind of compound to sediments, we can simulate sediment transport, and then we can know the temporal dynamics of the sediments associated pollutants. And then another for the soluted emerging contaminants, we can also include some uncertainty analysis, like to use Monte Carlo simulation to look at the uncertainties when simulating this kind of compounds.
Thank you very much. Paolo?
I was thinking that a common problem when you want to simulate the transport of substance with the water is to identify the source and particularly to quantify the magnitude. So maybe a way to complement detailed observations, which seems to be difficult for the moment, it could be to do some kind of generate an inventory at the larger scale of how much of these products are produced, how much of them are disposed into the wastewater treatment plants, for example, just to have an order of magnitude of the problem.
Thank you very much. And then we finish this round of questions with Božidar.
Okay, as a participant told before, it is not possible to analyze all these emerging contaminants that we have enlisted in the project. So we have to choose the representatives of the groups of them, and then set the thresholds, and then to monitor those. And after that, we have to set up procedures and practical methods for analyzing, because we don't have it now.
Thank you. So I would have another question, Joanna, if I am allowed to ask, or should we close?
I think we could continue if all panelists will agree.
I would like to ask a very final question. Taking inspiration from the talk of Manfred, in which he said, considering that continuous advancement of the technologies that we have available, we are monitoring also extremely low concentration. Therefore, zero pollution as a target is something like a dream to achieve, but is not practicable. But we also talked in this conference a couple of times about risk. So we are aware to some extent that it's not only the concentration of the contaminant that is playing a role, but it's also whether or not we have a target and what is the exposure time towards this substance. So in your opinion, would be then a path to follow, more than talking about zero pollution, to talk about as a possible target to achieve, to reach zero risk for groundwater supply? Or would this target also be just a dream, let's say? So again, we can proceed.
Gabriele, I think that zero doesn't exist in the real world. So I think we can address the minimum risk. And the meaning of minimum depends on our knowledge about the topic. I think that 10 years ago, no one of us was discussing about emerging contaminants, and now we are discussing about the risk posed by emerging contaminants. So I think we need to tend to minimize the risk to the best of our knowledge, and this is not a fixed goal, but is a goal changing day by day based on scientific knowledge.
Thank you. Nataša?
Yes, our limits of detection is by now about 1 nanogram per liter. It's extremely low for some parameters or some substances. For other, like estrogens, it is very high. When we talk about risk, we must consider from whom is that risk. For water organisms, the risk is much lower. So, like on the other hand, for the people. And also, as lower we go, the possibility of contamination by the sampling crew or the analytics is much higher. So we must consider that personal care products are everywhere around us, and contamination risk by sampling or analytics is very high. So this zero, I think, in analytics doesn't exist.
Thank you very much. Anna?
Yes, I totally agree. I think the more we look for, the more we will find. The chances that we will find more difficulties than less is quite high. I think that this discussion about emerging contaminants needs to be taken to the more sociological, should have some more sociological perspective. I think we here working as scientists, we know quite a lot about the risk of emerging contaminants in water environment, but I think that there is still too little information given to the real world, to people, to consumers, and it is really up to them and up to their behavior what we will find later in our waters. So I think this all needs to be upscaled to the discussion in a much broader environment. Thank you.
Thank you very much. Manfred?
Yes, this is the core of the discussion here in Austria on the national level. What kind of risk we discuss? Is this the kind the risk to fulfill the limit for the human health, for the water organism, for the environment? What kind of risk we like to discuss? This is not clear on the national level and also on the EU level. And I think this is a little bit dangerous for the water, from the point of view of the water suppliers, because we are on the end of the line, on the chain, and we have to deal with a concentration of ECs in our groundwater, in our raw water. And what we can do, which is only one measure, what we can do is treatment. And so we like to discuss also the risk at the point of source. What is the risk of a substance, of a pharmaceutical or chemical substance, that we find this substance or metabolites in the water circle? This is a very important discussion about the kind of risks we deal with. Thank you.
Thank you very much. Daniel?
I also think that this discussion goes far broader than just considering emerging contaminants, because the terminology of risk has to be dealt with from an integrated perspective. And this goes beyond the question of emerging contaminants or any kind of substances, or it does not even has to be a chemical risk we're looking at. So it has also always be considered from the point of interest we're looking at, and then to find ways to look at the communities that are living there. And communities means humans and any kind of living. And by that, I think, and this is the way to go, I think, to be independent from what might cause the risk, but being holistic in terms of assessing the risk.
Thank you. Jan?
Yeah, I agree with others. So first we have to define, or we have to find where is the risk coming from, and because, so for the zero risk, I think it's our final goal, but it's at the present, I think it's really hard. But what we can do, we can minimize the risk. But for different systems, I think the risks are quite different, because even with the same emission rate for different systems, such as the caustic system and non-caustic systems, then the emerging contaminants can have different residence time. That means we have different degradation potentials, which leads to a different risk. So in the future, or now, we have to take different measures for different systems, even with the same emission levels. So that's I think we have also to take some measures to maximize the degradation of emerging contaminants before we are using the water.
Thank you. Paolo?
Yes, I don't have a clear answer, but maybe I can add a comment about this gadolinium that I mentioned in the presentation. I was really surprised that a substance that is used only for very specific medical exams is detected far away from any possible potential source. And that's the case that I reviewed few articles about the subject. So that, I think, make this problem different to others, because it means that sources that are quite small and that can be distributed in different places can contribute to pollution or to concentrations in places that are very far away. So I think maybe looking at the sources or trying somehow to make an inventory to identify potential sources could be also a complement for trying to control this.
Thank you very much. Božidar?
It is difficult to answer this question, because all we can do now is to collect data and to set up good monitoring. In this phase, we even don't know which are the hazards, and we have to set the limits, and we have to include risk management experts to assessment of the risks and for future actions. And everything that is said here is okay, but that's why we have to have the holistic approach. We have to engage all experts and scientists. Now this is the beginning. This is we have to raise awareness of the problems of emerging contaminants, and there will be in future the new ones. So we have to set procedures and to go on with controlling these substances.
Thank you very much. I think it was a very nice discussion. I really appreciated your answers and your comments, and I think we gained a nice overview about the topic, also considering different point of views from researchers, from stakeholders, from water managers, and we have seen that approaching the problem from different perspectives can give us some important inputs also for the project in order to know what we should pursue in the next steps. So, Joanna, maybe you want to say some few words in order to conclude the midterm conference.
I would like to invite Josip Terzic to summarize the conference. I hope Josip is here. Josip? Okay, maybe he's not available. In general, I think the meeting is pretty successful. I think this was really fruitful presentation of both panelists and also presenters from our side, from our project side. Thank you for participating. I think there's a lot information now. I'm also reminding about the Q&A session. You can use the survey, ask us a question. We will answer it soon. At the end, I would also ask you to, because it's a European project, we also obligate to make some feedback survey. In the chat, my colleague Alexandra will paste the link to the survey, and we kindly ask you to fill in the survey to give us your feedback. What do you think about the meeting? There's a couple of questions, really short question. You can grade us from 1, it's the worst value, up to 5. We really count on the best value in this survey. So please fill in the survey. As we pointed before, the record will be available online. I'm not still sure if it will be whole record of the conference, or we will cut it into pieces, which will be maybe more suitable to use after the conference. We will see, but generally the presentation, most of the presentation will be available online. So once again, thank you for your participation. Hope to see you again pretty soon, because I see that we need this communication between stakeholders, because the feedback, the input of stakeholders is really important in this project. It's really important for our work in this project. So thank you again.
Joanna, wait a second. There are a couple of questions, I think.
Okay.
One from Manuela.
Yes, Manuela.
I only ask you if I use 20 seconds of your time to promote a conference on sustainable technologies for water and wastewater.
Yeah, sure. Please go ahead.
Thank you. I show you the slides. It's easier to promote this. I think you see the slide. This is a conference, the 5th edition of a series of conferences on sustainable technologies for wastewater treatment and management. And our goal is to promote synergic interaction between the various stakeholders and policymakers around the field of wastewater treatment and management. So if you are interested, please visit the website. Thank you. It's 20 seconds.
Thank you very much for this time discipline also.
It's an International Water Association conference, so if you want to share with us the interesting results of boDEREC project, you are welcome.
Thank you. Thank you very much for your invitation. So once again, I would like to thank you all participants to participate in the evening, and I think the event is closed right now. It's finished. Thank you very much.
Thank you. Bye.
Bye. Bye-bye.